I'll actually just launch into this. This is Kevin Powell, and I am the Director of Emerging Technologies here at GSA. And I really want to thank all of you for joining us on this, this first GPG Outbrief. We've launched this Outbrief series to help us more broadly share the outcomes of the evaluations we have done over these, actually we've been at this for about 5 years. And really you could say this is our way of inviting you into the forest so that we can be sure that if we're felling trees, somebody is going to hear that. Next slide, Andrea. Just a couple of words about what the GPG program is about. We stood this program up at GSA 5 years ago to help guide us, our agency, in identifying what next generation technologies are out there, and then how do those next generation technologies perform under real world conditions. What is their real world performance, and then the idea from all of that is to select the best of the best and to have GSA really make its investment decisions in those technologies that can have really the greatest impact. And we're here to talk about 2 of those today. I think it should be no secret to anybody out there on this call that we are in a very constrained funding environment. And I'm sure folks are hearing things like do more with less. Well, truthfully, I think the best way to do more with less, and perhaps the only way to do more with less, is really drawing upon innovative next generation technologies and approaches. If you think about that, that's how productivity gains and performance improvements have been achieved for really quite some time. So next slide. It's really it's a great honor to be able to have this panel with you today. Aside from myself, we have Mike Lowell, who managed these projects for the GPG program. We have Howdy Gowdy from Lawrence Berkeley National Lab, who was the principal investigator and research manager for these 2 technologies. And then we have 3 facility managers, and that's, I think, really it's incredibly important because these 3 gentlemen all really can speak to the true experience of kicking the tires of these next generation technologies. So again, thank you, Daniel Wong, Aaron Rock, Richard Kuhlman, for joining us this morning. So with that, let me turn this over to Mike, who's just going to give a quick overview of what we're going to do over the next hour and a half.
Thanks, Kevin, and thank you all for joining us on this webinar this morning. Today we're going to talk about, as Kevin said, 2 low-cost window retrofit technologies that showed very great promise in GPG testing. Those 2 technologies are the low-E window film and high-R low-E window panels. Thanks. Next slide.
And I just wanted to say, Mike, thanks very much for that, to remind people that if you do have questions, you can submit them through the chat window all along, and then we'll be answering them at the end of the presentations.
Notice on this slide that 34% of HVAC energy in commercial buildings is lost to windows. This is probably especially pertinent to these 2 technologies, as these 2 technologies are really mostly focused upon buildings that have single-pane windows. And I would imagine that in those buildings that have single-pane windows, conceivably they might be losing even more energy than what is indicated on this slide. So therefore, these are really, for when it comes to buildings with single-pane windows, these 2 technologies really have great promise. Next slide. And with that, I'm going to turn it over to Howdy Gowdy, who's going to present on the two technologies that were tested. Thanks.
Okay, thank you. So I don't know, Andre, are you still controlling the slides? Because I was just transferred to share my screen, but I thought that was going to be coming from you. So
I can control the slides.
okay. So I'm no longer seeing the screen because I was asked to share mine, but I don't. Okay, there it's coming back. So thank you. My name is Howdy Gowdy. I'm with the Lawrence Berkeley National Laboratory, and we investigated the higher low-E window panel technology. Complete window replacement projects are expensive and invasive to building envelopes. Typically, they don't have a fast payback in the installed cost with energy savings. But as Michael pointed out, windows have a large energy impact in the building as well as on occupant comfort. And all these factors motivate a lower cost, less disruptive window retrofit technology that adds layers of glass to the original package rather than replacing it. So next slide. And you're probably already familiar with this concept of the so-called storm window. There are different configurations that don't necessarily look like a typical residential storm panel that are usually mounted on the exterior of the building for only part of the year. A commercial building retrofit panel is typically mounted on the interior of the original glass, and it's left in place year-round. It does not change the exterior appearance of the building, and it doesn't require construction work at height for a multi-story building to install because everything's done from the inside. And the window panels improve air infiltration of the base window if there's leaky frame seals, because a new seal around the additional panel is created when it's installed. The panel also improves the thermal performance of the older frame because it's covering over the older frame if it's installed with an airspace. If it's directly installed to the frame, that's a little bit less of a benefit.
Howdy, I just want to interrupt. We're getting some notices. Can you speak up? Some people are having trouble hearing. Thank you.
Sorry about that.
No problem, thanks.
So it's not typical practice to have operable windows in commercial buildings, but it is important to recognize that using a high-R window panel will prevent operation of venting windows. So this might be a condition in historic buildings, although often they're still not operated, even if they are operable. So next slide. So these high-R panels were tested in a 1970s vintage building with single-pane aluminum frame windows in Provo, Utah. This was a relatively small single-story commercial building, and all 21 windows in the building were retrofitted. The retrofit project studied was a very highly insulating triple-layer panel, meaning that it had a total of 4 layers, counting the original glass. And winter and summer conditions were monitored for temperature and humidity between the panel and the original window and other surfaces. So next panel. So savings were significant. We showed 41% HVAC energy savings associated with the higher window panel retrofit. Whole building energy savings can vary greatly with many factors, including the use type and internal loads of equipment and people and et cetera. But that would be expected to be at least 11% in this case. The payback for this particular triple pane panel was less than 9 years, but we feel like a panel with fewer layers will have a shorter payback, and as you'll see later, maybe a better choice in most conditions. So next slide. So this is what I was alluding to. a triple pane attachment panel is very high performance, but we do see diminishing returns in energy saved for the investment in the product. So you can see in this graph that 39% savings is achieved just with the first additional layer with a low E coating. So a single pane retrofit panel with a low E gives you 39% savings, which is really substantial, and that would be a lower cost product to install. A double pane unit that's attached to the single original pane would provide 51% savings, which is again a good incremental gain. But by the time you add that third layer, you're only going to 53%. So that's what I mean by the diminishing gains, that you're better with those first conditions in terms of the energy savings for the investment in the product. So next slide. So the potential for condensation was a concern going into this project. Turns out it did not occur during the test at this building, and other installations have not reported problems, but it remains a potential that is worth evaluating. And the current concern basically is, because you're adding insulation on the inside of the original window, if you have warm, moist air from the room that can migrate past that new insulating panel to the outer piece of glass, the inside of the outer piece of glass, that glass is now colder than it would have been because it's insulated from the room and it's closer to the outside temperature, and so you could see condensation there. But the insulating panels are sealed well to the window opening, and so they try to prevent that. With that, I'll pass it on to Daniel, the facility manager.
Hi, everyone. This is Daniel Wong. For those of you that don't know where Provo, Utah is, Provo is located about 45 minutes south of Salt Lake City. On the slide screen right now, you'll see some of the other places where we use high R, low E window panels are in different regions around the country. We have had some reports back from a user in Region 2, GSA Region 2, which is in New York, who said that even in the hot, humid weather, they are still not seeing condensation forming on their window panels. So that has been a very positive thing. Okay, next slide, please. So just to kind of give you some idea on the windows themselves, one of the things that our tenants really noticed was that the thermal comfort of the window panels was dramatic, where those occupants that had cubicles or offices directly adjacent to a window, they found that that the air infiltration was reduced to almost nothing. And so the cold from the winter was not coming in and affecting them. And additionally, even if there wasn't air coming in from the outside, just being next to a single pane window, the temperature difference right at that window and a little bit further in, it was pretty dramatic. And they often felt cold sitting next to these windows. As you can see from the first from the pictures that I have on the screen right now, you can see that it really does look like a storm window. It is just an insert that is placed on the windowsill and then mounted and slid into place in front of the existing window. So the nice thing about the installation is that we had to move some cubicle parts, not even entire cubicles, but we didn't have to have the offices empty. We didn't have to move our tenants into swing space or anything like that. And so it allowed the installation costs to be a lot less for us as well. And then for historic purposes, because they're a window panel that's being slid in, we're not making a whole lot of impact on any historic fabric in the building itself. So that was really positive. The other thing that to note is that in one of the pictures you can see a mini blind shade holder. The one thing that we did find during installation is we had to remove some of those from the windowsill itself so that we could fit the panels in and then have to put the shades back up again. But overall, the installation was very easy, and it did not affect the tenants a whole lot. Next slide, please. So as Howdy said, this is a relatively small building, but the positive about the fact that it was a small building is we were able to replace all 21. We were able to add these high-R panels in front of all 21 windows. And as a result, we were able to really make a big difference to the entire building. And so while it's a small building, we saw huge gains in our energy usage. They made a big difference on heating and cooling demands in the building. And using advanced metering, we were able to see a substantial decrease in energy consumption from the prior winter to the winter after we installed these panels. After 4 years, the panels continue to work well. We have not had any problems. New employees don't even realize that window inserts have been installed. And we've not had any of the panels fail yet. The other really positive thing about this, in fact, is that the insulating value of the windows now is actually greater than the walls that are right next to the windows. So these windows have done a terrific job, and we are really happy with them. And that's all I have to say. I'll pass it on to the next presenter.
Okay, so this is Howdy Gowdy again with Lawrence Berkeley Lab, and we're going to pick up with the other technology that we studied, which was low emissivity window film. And again, complete window replacement projects are expensive and complicated to install. Climates without particularly cold winter might not be as readily suited to a higher panel retrofit. And so there are really a large number of commercial buildings in hot or mixed heating and cooling climates that have single pane glass and use tint or window films for control of direct solar gain through the window. Direct solar gain has a large energy impact on the building as well as occupant comfort. Applied films have been used for years and have done a good job of reducing cooling energy demand at a low installed cost, but they do not add to the insulating performance of the window. So next slide. So that enter the low E applied film, which is a special type of applied film that has a room-facing low E surface, and it offers the unique additional feature of improving insulating value along with solar control, which yields greater energy savings and occupant comfort. Direct sun falls on the window. It's largely reflected back outside. The majority of the reflected energy is in the infrared part of the solar spectrum that is invisible to the eye, so it does not change the visible appearance. The solar infrared is 50% of the energy in the solar spectrum. Long wave infrared, which is, different. It's not emitted by the sun, but it's emitted by, objects in the room and other things that, lower temperatures, lower temperatures than the sun. So that long wave infrared is, emitted by, room objects and reflected back into the room by this low E surface on the applied film. And it also means that low E surface on the applied film does not radiate according to its own temperature, whether it's warmer or cooler than the room. So this is where we're getting our thermal insulation benefit by eliminating this radiant heat exchange, as well as occupant comfort, because sitting next to the window you don't experience that hot or cold window surface. So next slide. So we had 2 test locations for the low E applied film. Ogden, Utah was a climate that requires a mix of heating and cooling, and Dallas, Texas, which is a climate more dominated by cooling demand. all orientations on 3 floors. The lower 3 floors of the Ogden building were retrofitted. The top 2 floors were left as original. You can see an appearance difference in this image on the left because this was the north side of the building that did not previously have any film on the glass, and so you're seeing the comparison of the low-E film on the lower floors and basically clear glass on the upper floors where you see through and you see the shades or lack of shades more readily. The Dallas location had a smaller retrofit installation with portions of 1 floor retrofitted on both the south and the north orientations, and both of these sites were monitored through winter and summer conditions. Next slide. So this is an infrared thermal image that is demonstrating the difference in radiant energy leaving a typical window with an applied film that's absorbing solar energy, getting hot, and then re-radiating that into the room. That's the window on the left that appears red. The window on the right has the low-E applied film, and as you see, it shows up as blue, or the cooler end of this temperature spectrum, because it's effectively reflecting the thermal radiation from the interior, room temperature surfaces, the walls around it, rather than emitting according to its own temperatures, because that glass is actually about the same temperature as the window on the left-hand side. It's just not emitting radiation consistent with that higher temperature. It's emitting a reflection of the surroundings, which makes it more comfortable to sit next to. Go on to the next slide. So in addition to the measured results in Ogden and Dallas, we performed modeling results that compared several diverse climates. There was consistent annual energy savings across a wide variety of climates. Most of the savings show under the cooling load, but the heating energy performance should not be underestimated because it definitely did provide heating savings, but more importantly, the heating energy, if it had not been a low-E coating or low-E applied film, would actually have required more heating than a typical non-low-E applied film, because anytime you control solar gain, you're doing that year-round. So it's beneficial in the summer to keep the heat out and make the air conditioner work less, but you're also keeping that heat out in the winter when it could offset some of your heating demand, and so there's often an increase in heating energy in the winter when you apply a solar control product, and so the benefit of the low-E applied film is that it improves the insulation and it offsets some of that lost solar energy, passive solar gain to the building. And it's really the reason the heating showed up small in the clear, when we compared it to covering a clear window, is a clear window has a lot of passive solar gain in the winter that offsets heating. But when we compare it to the single bronze base case window, the heating savings show up more dramatically because there's already some of that sun being cut out in the winter. So you can go on to the next slide. So, as the table of results indicates, averaged over all those climates, we saw 29% HVAC energy savings. And because of the way we were modeling it, that was, sort of for the perimeter of the building. It's, depending on the configuration of the building, that number could be reduced for the whole building HVAC energy savings, but it's not expected to be less than 1/3 of that, probably much better. We conducted occupant surveys, mostly related to thermal and visual comfort of glare, and those were for both summer and winter comfort and conditions. There was a very positive reaction to the comfort improvements with these low-E applied films, and the strong energy savings and reasonable installed cost make for a short payback compared to other efficient window technology, especially if you're just considering the incremental cost of this low-E product when replacing a typical applied film at the end of its service life. The payback might be 2 years or less. But even with a full payback and over a variety of different base window configurations, the payback was less than 6 years in all the climates that we looked at. So, next slide. So,
hold on, Howdy. So we're getting notices that people can't hear. I can hear you, so I'm not sure. That's interesting. Since I can hear you and nobody else can. Okay.
I can also, but so maybe some people need to sign back in or dial in.
They're still showing up. So a bunch of people can hear. Okay.
Looks like Kevin might be having his own issues if he's the one who says he can't hear.
But I guess Richard also couldn't hear, and Daniel.
Okay.
And Daniel can still not hear.
This is Aaron, and I can hear you guys loud and clear.
Okay, great, thank you. Okay, I think that's a good idea. For the, why don't you try dialing back in?
Well, hello, can anyone
They can't
hear me?
hear me. Yes, who's this?
This is Daniel Wong.
Okay,
so
you dialed back in and we can hear you now?
Actually, no, I didn't do anything. It just suddenly popped back up again.
Just suddenly popped back up? Okay.
And ditto for me, Andrea, ditto for me.
Interesting. That's a new, well, we're still figuring things out, so that's good. We'll carry on. Thank you. Thank you
Okay.
all.
Did you want me to go back to a previous slide or anything?
Could you
I'm okay.
Yeah, I think it's okay, but can you just quickly summarize what you might have said over the past, say, 2 or 3 minutes?
Okay, well, we just went over the savings slide for low-E applied film, and basically said the average savings was 29%. It's a little lower for whole building HVAC. Occupant surveys were very positive about thermal comfort in both summer and winter. And the strong energy savings and reasonable installed cost of the low-E applied film makes for short paybacks relative to other efficient window technologies, and especially in the case of an incremental cost, if you are already replacing an existing applied film at the end of its service life, the payback might be 2 years or less, but a full payback over a variety of climates and base window conditions is still better than 6 years in all the cases we looked at. So,
thank you.
All right, so back to next slide, so because window performance and the selection of the right product is generally dependent on climate, orientation, shading, and other factors, it's always advised to conduct site-specific analysis. However, as our modeling results indicated, the low-E applied film appears to be less sensitive to at least the climate factor because of the improved thermal performance, offsetting the loss of passive solar winter gains. And so, we can be a little bit more confident about a broad deployment of the product because we don't have to worry about that trade-off as much. There are, I should have mentioned, there are different visible transmission versions of this film that have more or less of a visible tint to them. We studied the VT35 or 35% visible transmission product. The manufacturer has also just introduced a 50% visible transmission product that allows a little bit more daylighting. So in many cases, occupants highly value daylighting in their workspace just as a improving the quality of the workspace, and so in situations where natural daylight harvesting is a high priority, the 50% version of this film may be a better choice. It comes with trade-offs. Maybe there would be more glare issues, or so that's again a site-specific analysis, really understanding what the building needs and what the occupant preferences are. Test applications can help with understanding the subtle. There are visible appearance changes. They're not dramatic, but if in question, it's never a bad idea to just test it out and see on a smaller area first. All right, the next slide. So both high-R window panels and low-E applied film are effective energy-saving window retrofits with cost-effective payback periods and minimal disruption to occupants during installation. Higher panels are best suited for colder climates. Adding a single low-E attachment panel is a highly cost-effective, and a double-layer panel may offer more savings where needed. Low-E applied film can improve the thermal performance along with solar control and even more economically by adding, well, it's a lower installed cost than the higher panel, but it will not improve air infiltration of a leaky base window. So that's another thing to consider if you have, a concern about air infiltration. The higher panel is going to be better, but if you're in a more moderate climate or don't have a really leaky base window, the low-E applied film is probably a more natural choice. The low-E applied film has a reasonably short payback period under most conditions, but is more favorable as a replacement for existing window film when it needs to be replaced for other reasons. Typically, applied films have about a 15-year service life. The low-E film is about the same. And so, if you're nearing that replacement period, the low-E film is really an obvious choice to upgrade to. Higher panels, because they're typically glass and framing materials that are similar to the base window, result in longer lifetimes, probably 30 plus, 50 years, but it's a very different type of product, and installed costs are different as well. So both technologies are applicable to the retrofit of historic buildings that can't use a complete modern window replacement. Low-E film can introduce some visible reflection and color shift that might be an aesthetic issue for some historic buildings. So again, it's important to look at that, but both of these don't really change the exterior appearance of the building significantly. And they both have relatively low installed costs, and the tenant impacts are quite minimal because they can be installed from the inside incrementally, often after hours, and it's not as big a deal as actually opening the building envelope and that level of disruption. So I think with that we can pass it on to Aaron, who is the facility manager at the Ogden, Utah site.
Hello, everybody. And if you're wondering where Ogden is located, Ogden, Utah is located about 45 minutes north of Salt Lake City. Some of the observations that I saw and some of my customers saw, that those who were sitting next to a window with the new window film who also had the old window film removed and replaced, that they noticed a big difference in their comfort as far as the heat gain sitting next to the window during the summertime, that they felt more comfortable. Another observation, and I apologize that I don't have any pictures of this, but this new film, it's very nice to look out of, especially compared to our old film, but even compared to some other window films out there, that it has a nice kind of a golden touch to it. And I like to compare it to, if you have like a pair of nice sunglasses, that it's like looking out of a pair of sunglasses. And another observation that I made that is on our 4th and 5th floors. Our 4th floor has the new window film. The 5th floor has the old window film. But during the heat of the day, when the sun's on that warm, hot west side of the building, that the 4th floor tends to do better. That when I look at my building automation system, I notice that the temperatures on the 4th floor will be more in range of what we want, that the AC is able to keep up on the 4th floor. But on the 5th floor, we still tend to struggle, that it will be a couple degrees warmer when I'm looking at the temperatures there. And so those are just some of the benefits that we've noticed from the window film up here in Ogden. And thanks, and I'll pass it along.
I'm Richard Kuhlman. I'm the building manager of the Earl Cabell Federal Office Building in downtown Dallas. I think everybody knows where Dallas is. We certainly advertised that fact. But the complex itself consists of 2 buildings with about 1.5 million square feet. So these kinds of studies are very useful to us. First of all, I want to reflect my experience is consistent completely with what Howdy and Aaron have said. I was actually just a customer during the early part of this project, where I was seated next to a window. We're all on the south-facing portion of this, that is the picture that you saw initially. And I was not the building manager at that time, but I can confirm that from an occupant's perspective, the installation was very simple. I don't even think I knew when it happened. But I want to say that it has been a successful test for us. The southern-facing portion of the building is where the GSA offices are. We get full sun most of the day and basically most of the year. For occupants, the comfort level is quite high. There's certainly no increase in the discernible heat load near the windows. In fact, again, as a customer, I believe it was reduced. From an interior perspective, out through the tent, I agree with Aaron completely. The effect is very lightly reducing the glare that we would receive in this area from the afternoon sun, or really the morning sun on our side of the building. Aesthetically, typically window films tend to change the nature of the building. We've had several people, including myself, out to look at the delta between the filmed windows and the windows that were untouched, and literally there's no discernible difference. There are a variety of surfaces and colors on the exterior of our building, but the tint is literally no factor. So that's a nice thing as you move forward. The north side of the building was also protected. A portion of it, I didn't get comments from those people, but it's a large floor. We're almost an acre, over an acre in size in our building, so a lot of people along that north line. No comments, no negative comments. Positive comments mostly came from those of us on the sun side, and they were all positive. So our experience with this project has been very good. We would be certainly a building our size has $2 million plus of utility costs, so that's something that money, and we would be supporters of a continued retrofit. And I'll pass it on.
Okay. Thank you, everyone, for your presentation. I think we're ready for questions. Let me flip to that screen. First question, 11% whole building savings seems very modest if the HVAC energy savings were 41%, especially in a cold climate. Any insights on this?
Yeah, so this is Howdy Gowdy with Lawrence Berkeley Lab. I can take that. You know, whole building energy includes a lot of things. You know, it includes lighting, equipment, and so as was shown on that first one of the early slides, where you know, as a approximate national average, 1/3 of heating and air conditioning energy is lost to windows. You know, you can, well, it's not exactly the same thing, but basically, if you took 1/3 of 41%, you actually get something close to 11%. But you know, it's basically just that there's a lot of other energy consumers in the building, and that relationship can vary a lot. I think in this particular building, even though we showed a very strong HVAC savings, the building was small, and so the ratio of the perimeter of the building to other internal loads was perhaps such that it wasn't as noticeable. You know, if you have a lot of computer servers or something running in the building, that might outweigh it. So that's a few comments on that, but certainly the reduction in energy going through the windows is dramatic, and there is a large component of window energy in any building's energy bill, but there's many other factors to consider. So.
Thank you. Are there any issues with operability? And I'm thinking Howdy, especially operable windows, with respect to the high R panel.
So yeah, typically the high R panel is going to cover the complete interior side of a window, so you can no longer reach it to operate a movable sash. But as I said, in most commercial buildings, that's not commonly done anyway because of the way that people want to operate their HVAC systems and maintain balancing and things like that. If it is a building where people are really, expecting to be able to manually operate windows, then a higher panel may not be, the best choice. The low-E window film, because it's an applied film, does not disrupt the operability of the window, so that could be an option for you. Or it's possible. I mean, I've not seen this for the commercial products yet, but some of the participants may be familiar with residential exterior storm windows that are called triple track. They typically have a sliding sash in the outer storm window as well. So I mean, it means you have to operate two separate layers, but they do maintain the ventilating possibility. But I haven't seen that on commercial windows. But I think in the case where operability is really a high priority to maintain, probably looking at the low-E window film makes more sense. But you should really establish whether people are using and operating those operable windows, because even if you have operable windows, say in a historic building, if they're not being moved, they might have a lot of air infiltration at those sash seals, and actually applying the higher panel over that could be a big insulating benefit if people aren't operating them. So that might even mean just choosing to retrofit the windows in strategic locations that don't get operated with that kind of technology, and then using maybe the applied film and other places if that's a practical solution.
Thanks. Hattie, another question for the inserts. For the window inserts, please share my data or any data on required sill depth, as well as U values and ROI. Did you hear that? Yes.
Yeah, I'm trying to understand what was fill depth.
Well, so yes. So how deep does a window sill have to be for the insert to be used?
Oh, I see. Okay. Well, so the drawing the photo that's up right now shows sort of the window pocket that was available in the building that we retrofitted, and you can see, because a typical wall is at least 4 to 6 inches thick. I mean, in commercial buildings, often more. There's a good deal of space on the sill and jamb around that existing window where the retrofit panel can slide in and seal against that opening. Typically, those the frames on these attachments vary from maybe a half an inch to less than an inch and a half thick. So I would say as long as you have a couple inches to be conservative, you should be able to install one of these products. There are different designs with some attached directly to the existing frame. Some are expecting to kind of push sideways against the jamb. But I think it's fairly typical to have a pocket on the room side of at least a couple inches, and that should be sufficient to install pretty much any of these. And some may be able to work with less. So you asked about also the properties, R values, and solar heat gains, I guess. So the properties can vary quite a bit. As I said, we installed a very highly insulating triple layer assembly in the test building. You could start with a single pane of glass with a low E applied film that faces the glass or faces the existing layer. That would basically move you to the performance from single pane glass to close to a typical modern, sealed double pane unit. And obviously, adding layers and adding coatings, you could pretty much build any configuration you want, depending on what's available in the market. But generally, you would be moving towards the overall, from a typical sort of R1 window, single pane window, you'd be closer to the R3 range, or even higher if you had multiple layers. As Daniel said, the windows that went into that building actually turned out to be more insulating than the walls because it was an older vintage building that had pretty modest insulation. But likewise, the solar control of an applied panel is determined by what coatings are on the glass. So you could have a strongly solar control low E film on the applied panel, or you could have something that accepts a little bit more solar gain. Typically, the commercial buildings benefit from reducing the solar gain, but depending on what your base window is, if it's already has a tint or solar control to it, you wouldn't want to add a really strong solar control on top of that, because then it might get too dark in the space, or you just are kind of overdoing it. So you always want to be sensitive to what your existing condition is, and luckily there are some selection of products to choose to allow you to match your or existing condition.
And I just want to jump in, Howdy, that you can find more information on the GPG website where you can download the findings. I brought those up right now showing the U factor and solar heat gain coefficients. So you can find those both in the findings, and there's even more detail in the full reports.
Right. And then another question, what sort of E-values are achieved by the VT35, VT50? And I thought we might want to mention also that there does exist a VT70 as well. And if you could just quickly compare what performance characteristics you might see with 35 versus 50 versus 70. And I would think heat gain allowance and then also thermal performance.
Yeah. So so Michael mentioned there's basically 3 levels of visible transmission offered in the low E applied film, and they are mostly distinguished, by their visible transmission and the associated, solar gain control. As far as the low E property of those 3 films, there's slight differences, but they're all quite close, and they're very low compared to anything that's been available on, certainly an exposed applied film in the past. So they're about 0.05, which means 5%. So emissivity is basically telling you how much of thermal radiation that could be emitted by a surface is being emitted. It's basically just a scalar from 0 to 1 telling you, if it's 0.05, it means it's emitting 5% of what it theoretically could, which is a very good low emissivity. It's, similar to what you would have in a hermetically sealed, double pane low E window that would be bought, typically. So that's the low E property, which applies to the thermal performance. And then, as we said, there are these different visible transmission levels, which, they let different amounts of daylight through, but they also, are letting more or less solar gain, because the visible part of the solar spectrum is part of that solar gain. And, but it's, visible light is a valuable resource to a building, and it can offset, artificial lighting, and that has a, spin-off effect to cooling load as well, because artificial lighting dissipates heat in the space. So our study did look at, daylighting and electric lighting interactions, and so that can be another motivation to keep your visible transmission high, especially if you have sophisticated, daylighting controls on your lights that, dim to make up the difference needed above what the natural daylighting is providing. So.
Okay, thanks. Howdy, do you know if this low E film can be installed as blast film?
So I'm not an expert on blast film. I assume that there needs to be a specific rating for that. My understanding is basically any applied film does help to, hold fragmented glass together if it cracks, but certainly the more stringent requirements for blast ratings are probably a whole nother tier to be considered. But definitely, an applied film does help with safety of broken glass, but yeah, it may not be rated for, the more stringent requirements.
Thank you. And then are you aware of the high-R panel coming in a residential form?
Yes, there are certainly residential panels that as I said, there's a kind of traditional residential storm panel that was often installed on the exterior of a building, and people would, take them up and down seasonally. There are certainly interior options that are available these days as well, and you can still choose to, some of them have kind of, if they're not, a heavy glass panel, some of them might use a rigid plastic layer or something. They can even use like magnets to attach to a perimeter on the window frame, and that can be taken up and down as well. So I've seen various residential products like that.
Thanks. And so we're at the end of the hour. And one thing I will tell you, I'm sure all of you have more questions. I know I've got a couple that we haven't gotten to yet. But again, this is Mike Lowell. I was the GPG project manager on this project for both of these technologies. And if you have further questions, why don't you send those to me via email, and I will put you in touch with those that have the correct answers. Kevin's going to wince when I say this, but one of the questions was, who was the manufacturer? For this film, we specifically tested a film produced by Eastman Films. And then, Howdy, I don't know if before we close, if you could just maybe share whether there are other manufacturers that produce similar films or what the differences might be between Eastman and what else is out there.
Yeah, so far, this is the only applied film product I'm aware of that has this low of a surface emissivity to improve thermal insulation. There are many solar control films out there. Some might even use the terminology low E because low E gets conflated with solar control sometimes. But what we're really talking about here is a film that adds thermal insulation properties by having an exposed room-facing low E surface. And what can happen sometimes is because historically these low E coatings have needed protection to be, they're thin layers of metals often, and they could, oxidize or something, and that's why they're in these hermetically sealed double pane units. In an applied film situation, they would often cover that coating with a thin layer of plastic or something to protect it, and that provided the solar control aspect of the thin metal films, but it didn't preserve the low E thermal performance. And so what this particular manufacturer has succeeded in doing is creating a durable version of the film that can face the room and provide that low E thermal performance. And I forgot to mention, there are some slight cleaning differences that they recommend, but otherwise it does not need to be treated differently than other applied films that are commonly installed in buildings.
So quick note from Kevin Pell here. There was some confusion as to whether we were going to go for an hour or an hour and a half. We actually booked this for an hour and a half. So if you guys can, in fact, stay on, for those of you who can, we do have quite a few more questions that I think will probably be of value. So for those of you who want to stay on, let's go through for about another 20 minutes. Or even potentially less, and cover a few more of these questions. For those of you who need to drop off, please, we thank you for your participation.
Okay, thanks, Kevin. So in fact, I'll ask Kevin's question, which is, do high R insert panels provide acoustical benefit?
Yeah, I would expect that they do. Again, I mean, our lab is not really focused on acoustical performance, but my understanding with the acoustics of windows is that multiple layers and the air spaces between them is what helps you with acoustics. Also, laminated glass is often used for acoustics, which means two pieces of glass with a sort of rubbery membrane sandwiched in between them. But certainly if you attach a higher panel on the interior of an existing single pane window, you will improve the acoustics quite a bit, especially because if it's not directly coupled to the exterior frame, you're also buffering, noise vibrational energy coming through the frame as well. And that is another distinction between the low-E applied film and the retrofit panel, is that a low-E applied film would essentially do nothing significant for acoustics, but the applied panel, because it introduces multiple layers and air spaces, would.
Okay, and then
Mike, I'm wondering also if any of the facility managers have any thoughts, have any experience or thoughts on if they noticed a difference
on the acoustic performance.
On the acoustics, right?
That would be Daniel. Yeah.
Hi, everyone. This is Daniel. We did notice a little bit of an acoustical benefit. We didn't specifically measure for that. Because the old windows were single-pane windows, when we put the inserts in, and based on what Howdy said, because of the air gap and the gap between the film from the insert, the occupants were able to notice that they were not hearing as much street noise or noise from the parking lot.
Thanks. And then, Howdy, can you speak to the range of per square or installation costs for both technologies, let's say per square foot of window space?
Yeah, so I think for the low-E applied film, we had the number of average value of $7.75 per square foot, and that's including the material cost and the installation cost. There is a, sort of a certification that the manufacturer does for their installers. Just because it is a slightly different product, they want people to be trained for this particular product. And so there may be a slightly, higher installed cost associated with that, or, a little bit more process in the contracting to find, the manufacturer-approved installers. That wasn't really a problem for the installation sites that we tested the product in, but it's just something to be aware of as you go looking in perhaps the more metropolitan areas. It will be easier to find than perhaps in areas that are further out from large business centers. The cost of the installation can probably vary a bit, for different situations. One issue is whether there's existing film on the glass already. Then you need to remove it first, which adds $1 a square foot to remove the film. But again, if you're replacing existing film because it's at the end of its life, you have that cost anyway. It's not a new cost. And the other aspect to think about is, access to the windows for doing the work. I mean, sometimes some, furniture might need to be moved. It's a relatively non-invasive installation for both products, but I think in all the installations there were, some need to maybe reconfigure some modular furniture if it was built right up against the window or something like that. And that's something to keep in mind for the installation cost as well. I don't think I have current numbers on the higher panel retrofits. The product that was installed, that company was purchased by another company, and they're now offering slightly different products that I think are 1 and 2 panel layers instead of 3 layers. So I think the payback should be shorter than what we reported. So I would expect something maybe in the same 5 or 6 year range as the high end of the films. But yeah, unfortunately, I don't have a per square foot cost of the retrofit panels off the top of my head.
Okay, thank you. I just see one more question. And in quotes here, E is equal to 0.05. This sounds like it's based on AG. I'm not sure what AG is, but
Solar, I think. So most low-E metal-based films are based on thin layers of metal, mostly silver. As far as I know, this one is too, but it obviously has some extra proprietary magic going on to achieve the durable low-E surface that they have that none of the others do. So I don't know much about the details of the construction of the film, other than it is applied as a multi-layer metal thin film on a plastic substrate like other applied films, but obviously they have some special things. I do know that the highest visible transmission version, the VT70, 70% visible transmission version of the film, it actually has it uses some gold in its layer structure, and as a result, it's a much more expensive film than the 35 and 50% visible transmission. And we didn't really focus on it, and we presented the performance in our report, but because of the additional cost, we thought it wasn't going to be, likely to be a strong candidate in most buildings unless you really needed the high visible transmission for some reason. I mean, you could get, the performance that's desirable from either the 35 or 50% film very easily, and it's, a much more reasonably priced film.
I've got a question for the building managers. I think in the case of both technologies, which added some tinting, of course, did you notice any additional, once they were installed, did you notice any additional need for artificial lighting in the building? Kind of with reduction in daylighting.
This is Richard in Dallas. And of course, I was on the sun elevation, therefore there was no additional lighting required. We did also include a GPG LED lighting project, so we kind of had two changes going on at the same time. So we're trying to measure the effect of both, but no additional lighting was required.
And this is Aaron, and I concur that we didn't need any additional lighting. And actually, I think that this film, compared to the old film that we had, at least like looking out, was actually a little bit like brighter than compared to the old film. And so, yeah, we didn't have any need for additional lighting.
And I guess the other thing I would add is I think the hope is, or the thought is, that with these films and the reduction in solar heat gain, assuming that there are window blinds in the building, the thought is that people would reduce their use of the window blinds, which, in essence would actually perhaps even increase daylighting. Someone else is going to speak up as well. Sorry.
That's okay. Hi, this is Daniel. For the window panel inserts, there was a little bit of a change in the view out the window when the panels were put in. But we actually did an LED retrofit at the same time as well. And so we did not need to add any additional lighting for the panels that we installed.
And just to backtrack on what Michael just said, that yeah, we do have some customers now that will leave their blinds open longer with the new film.
And
okay.
This is Howdy. Just on those comments, I mean, I think it points out that sort of understanding your base condition has a lot to do with how these changes are perceived. Because as in Dallas, there was an existing film that already had sort of a similar visual appearance, but we added the low E performance by retrofitting. In Ogden, there were two different conditions. On east, south, and west, we had an existing sort of absorbing applied film, and on the north, they had none. So there was a much bigger incremental change for people on the north side than on the other side. And in the case of the higher panel installation, going from one pane of glass to 4 layers is always going to come at a sacrifice of visible transmission, because every layer that you add has an impact. And so it's not surprising to see some reduction in daylighting there. And it's another reason that sort of motivates the more optimal condition of fewer layers, which gives you the good performance but doesn't sacrifice as much daylighting. So.
Okay, thanks. And then everyone else, please help me. Let's see. I don't see any other questions that have been unanswered, I don't believe. Andrea, do you concur?
I concur.
Okay. The one thing I would stress before we close, well, 2 things. Of course, if you have further questions, contact me, Mike Lowell, via email, number 1. And then number 2, strongly encourage you, if you are interested in these 2 technologies, to look at the reports. And if you don't know this already, the laboratories produce lengthy assessment reports on the technology, and then Andrea's company produces what we call findings documents, which are typically 4-page summaries of the reports, so you can look at both. And as far as finding the Green Proving Ground webpage, the URL is kind of funky. It has a number at the end of it, yada, yada. But if you want to Google it, just, at least for me, I just Google gsa.gov/GPG, and then that brings up the URL in my search engine, or, brings up, a search that, leads you to GPG. I don't know, Andrea, if you have anything else to add to, how to find the reports and the findings. But. Kevin, any closing comments?
This is Richard in Dallas. I did see a question if someone who might have wanted to speak to an on-the-ground person. I'd be happy to speak to anybody about, in my experience here. It's, again, partly as a customer and partly as a building manager, so I kind of have both sides of it.
That's great, Richard. Thank you. And hopefully Daniel Wong and Aaron Rockwood, I know them both, and I know they're both very accessible people. So for those of you who want to reach back to them and to get more, sort of off the cuff and candid, you should definitely go for that. I'm really excited that we were able to hold this first outbrief, and I think that I look forward to the next one. And as you can see up there on the screen, that next one is April 27th. That one's going to talk about what are called wireless pneumatic thermostats. And this is essentially a technology that lets you achieve essentially 80% of the benefit of a DDC system. If you have a building with pneumatic controls, you can achieve about 80% of that benefit at less than 20% of the cost, because these are essentially a very inexpensive way of creating a network. That network essentially with leaving your pneumatic system in place. We had some great results there at NCR at the test bed, and now we're also deploying this in Region 2. So again, I think that'll be pretty exciting. Look forward to having all of you participate on that. And then, of course, in June, we're going to be talking about a couple of next-generation chiller technologies. I think that, from all indications, should be a very, very exciting presentation. I think many people are quite interested in these 2 technologies. Basically, a magnetic levitation chiller, our evaluation of that technology. We've actually installed quite a number of maglev chillers at this point. and then another technology, a variable speed screw chiller, which we found to have equivalent or better performance to the maglev. So that's actually quite exciting, particularly since the cost of that technology is a bit lower. Again, looking forward to continuing this series. Hopefully you guys have found it valuable. To the degree that there are things you would like to suggest that we change for the next outbreaks. Again, this is a learning process for us, and this was our first. Please feel free to email Mike or myself, and we'll take it from there, and we'll incorporate your feedback. So again, thanks to all of our presenters, and thanks to all of you for attending, and have a great day.